Good morning, friends. Welcome to this session on a live show on the use of SOFA statistics open for all. This is a free and open source software. It's a very simple to use. Just go to Google and type SOFA statistics and say enter. You'll get the website sofastatistics.com. You can click SOFA statistics open for all homepage and wait for a minute. You get the software. Fine. And they have softwares for Mac OS and Windows OS and even Linux and Ubuntu installer. Just give a click on that, the software will be installed, the single exe file, click, the software will be ready for you, you can use it. So very simple to download and very simple to use. And here, if you go to features or even downloads, videos, you'll get even some materials on how you can make use of this particular software. Even videos are available. When PDF documents are available, you can go and download those materials. And it's for Windows, Ubuntu, for other operators. If you want a source code also, you can take, okay? Because it's an open source software, so you feel that, sir, I would like to get the source code, the language, so that I will be able to write something, rewrite something. I want to change the software, the look and feel of software, something like that. No, we can make use of it using this source code because it's an open source software. Fine. And if you go to videos, they give you some videos on the use of this particular software. Either there's a quick overview or how to import data or how to import Google Docs spreadsheet and how can you connect this software to SQL database, how you can make tables and edit tables, how you can make reports, how you can make charts, how can you choose statistical test, how can you share your output, now how to filter the table data, how to recode data. See, all these things are there in the video form. Tutorials are available. You can go and download all these things. Fine. And this is about this particular software. Now let me close software. I have installed the software. Just a single click. This is a home page of the software. Okay, you can see the home page. And it has got two panels, left side, right side. The left side we have get started, enter, edit data, import data, Repo Tables, charts, statistics. On the right side we have online help, select project, preferences, run backup and exit. Fine. So as I told you, a statistical software will help you to enter or edit data. It will help you to import the data from recognized formats. It will help you to generate required reports. It will help you to generate required charts. And you can conduct various statistical tools and get the output. And these are the basic operations of any statistical software. And apart from that, you can take a backup of your all the statistical analysis. And you can just come out of software by clicking exit. Fine. Okay. For example, I have done a research. I have given a questionnaire to a good number of respondents. I collected the data. Now questionnaires are with me. I want to enter the data. Okay, I have got questionnaires or schedules, whatever it may be. I want to enter the data. So how to go about? Click on enter, edit data. You get this small screen. If you want to have a new table, you can say new. See, you got a questionnaire, you want to create a new table. So click on new and wait, you'll get this screen. Okay. And it is asking for the name. For example, you have conducted a study on internet. So I gave a name internet. Okay. So before you start entering data, you should create a kind of a worksheet. A plain sheet with only headings, name, age, gender. This worksheet should be ready. If this worksheet is ready, then you can keep on entering data. Okay. So how the worksheet is prepared? The worksheet will have only two items. What is the name of the variable and what kind of data is that? Whether that variable carries a numeric data or it is having a text data or it is an ordinal data, whatever it may be. See, two things are there. What is the name of the variable and what is the data type? You should prepare here. And if you see this particular screen, number one, SOFA ID is a default field which cannot be deleted, you can start from here. Okay, for example, my first one, you want the name of the candidate. I type the name, and here you select text because the names will be always in textual form. You can select next, then click enter. Then you want age of the respondent, and here data type you can go and select numeric. Okay, then press enter. I'm sorry. Then I want to enter some marks. Okay, maybe first exam marks. I click again numeric. I say enter. So this way you can keep on entering all the questions, and you can decide upon the data type. Okay, once these two things are over, if you are having 40 questions, you will prepare 40 data lines like this. This is over. Then say update. Okay, it says that your new table has been added. Fine. Click OK. You see now the plain sheet has come. You can start typing. You take the first questionnaire. You type what is the name? Okay, Rama. What is the age? He is 23 years old. How many marks is got? 45 marks. Fine. Okay. And second one. Second person, Kanda. Okay, he has got 30. His age is 34. And he has got 70 marks. Okay. Then we have Subha. She's maybe around 35, and she got 90 marks. Okay. And we have Arumugam. Okay, and we have just press tab to move to the next one. Yes, he's around 37. Tab, and he has got around 79 marks. Okay. Then we have Aravind. He's around 40 years. He has got maybe 75 marks. Okay. This way you can go and enter data once the worksheet is ready. Fine. You do not have any. You don't have any save option here. Just close it. It is saved. Okay. You can close. You can come out. So first day you typed 5 or 6 letters, and second day you want to open the same file and type the remaining questionnaires, or you have made some mistakes, you have not added something, you want to add something. Okay, for example, I want to add one more field. For example, I just go to enter, edit data. I select my file. What is the name of the file? Internet. So my file is selected from the drop down menu, internet, and I say not open, I say design. If you click design, this worksheet will come. You can go and add or delete things. For example, I want to add one question called gender. I want to add gender. So gender can be numeric. Why numeric? I'm going to allot some numbers, 1 for male, 2 for female, something like that. So I just keep it as numeric. Okay. So I added one more field. Okay. Say update. Okay. It is updated. Now let me open the file and click here, open. The file has come. You can see here now another extra column is added called gender. There I can go and type 1, 2, something like that. Fine. So before I do that, I should tell the computer 1 stands for male, 2 stands for female. I should allot values for I should allot some labels for the values. How to do that? Keep your cursor over the variable. Give a single right click. A box comes. There you can say 1 is male, 2 is female. By default, they have given. If you want to change, you can change it also. This is a nominal data. Here you can use a data type. There's a nominal data or ordinal data or numeric data. So gender and gender is a nominal data. I just leave it as such. I say update. Say it is saved. Say okay. You can go and type 1. Okay. Then this is Kandasamy again, number 1, and Subha maybe then Armums then, and this way you can go and keep on adding all questionnaires. Fine. So this is how you can create a plain worksheet. You can come and enter data. First step is over. Fine. If you want to delete the data, it's very simple. Once I come to enter, edit data, select the table, click delete, the file will be selected. And it will be deleted also. Fine. Okay, this is one thing. And secondly, some people, what they do is that they type all the questionnaire data in Excel sheet, which is very easy for them. We are very much familiar with MS Excel. So they go to MS Excel, they type all the required data in MS Excel. So if you have data in some such kind of formats, they can be very well imported into SPSS or this SOFA statistics for that matter. How to do that? Please have a look at this particular screen. Click on import data, left panel, third item, import data, click. It says that it can export and import CSV files, TSV, tab separated value, tablature file, XLS, XLSX, ODS, open document spreadsheet, something like LibreOffice, StarOffice and all, then Google spreadsheet. So if you have your data typed in any of these formats, those files can be imported into SOFA statistics for analysis. Fine. I just browse, I say browse. I go to desktop and our folder is there, Maya's to search. I have one file called Excel file to import. I select the file, say open. See, the name of the file is come here. Okay, you can click import. To ask a question whether your worksheet has got a header. Yes, my worksheet has header. Gender, marks 1, marks 2. This is my header. So click has header row. Click. Okay. See now successfully imported data as Excel file to import. The file is imported. Say okay. You can close. Now to see the file what you have imported, go to enter edit data. You can click the drop box, this arrow. You get all the files. Click Excel file to import. Say open. The file is ready. So this way, if you have data already typed in some such kinds of file formats, they can be easily imported into SOFA statistics. Is it clear? I think I'm clear with those two things. How to create a worksheet, how to enter data, how to edit data, and how to import data. These things are clear now. Okay, let me close the window. Now next is report tables. How to create tables. Click on report tables. Fine. And I have a file. Let me open the file. The file is descriptive statistics. There is a file called descriptive statistics. Maybe you'll be getting all these files for your practicing purposes. You click on descriptive statistics. Fine. Here, 4 options are available: frequencies, cross types, row stats, data list. 4 options are there. Let us see one by one. I click by default. The frequencies is clicked. So let it be so. I want to calculate the frequency of various questions, various variables. See, there is a table called my file, descriptive statistics. You can click on open to see how many fields are there. So this particular file has got gender, week 1 marks, week 2 marks, and nativity. 4 variables are there. Fine. So I just saw what are the various fields available in this particular file which I have downloaded. Fine. And I'm going to calculate the frequencies. Just below rows, there is something called add. Click on add. It is asking for which variable frequency is to be calculated. I just click gender. I say okay. You can see here, just come. Why 2 have come? I have selected 2 things by mistake. Let me delete one. I'll show you one by one. See, when I selected gender, you can see male 8, female 12. See, immediately the reply has come. Then under rows, there's something called a config. Click on config. Can click total. Say okay, so that you'll get total here. So male 8, female 12, total 20. Fine. Fine. Suppose if you want to add one more, go to rows, add, next option, nativity. Say okay. Can see nativity also is coming in the same table. So this way you can create frequencies for any number of variables. Either one variable with total, 2 variables, or many variables. You can have it absolutely no problem. So this way you can create very, very simple frequency tables. Once it's ready, what you can do is that here options are available. You can export whatever statistical test you conduct. Output will appear in this particular box, the white space, and whatever output is there, this can be exported. You can export the current output. Click on export. It will be saved as an Excel file. For example, I want to save this output. Okay, I click export. You can see here it is asking whether the output is to be exported as a PDF file or as an Excel sheet. I click that Excel sheet. I say export. You can see here the spreadsheet has been saved to your desktop in the SOFA export June 2. Okay, a folder is created, and this result is available there in the Excel format. Whenever you want, you can open it, and you can let me close the screen. Let me close this screen also. Let me minimize this, and let me go to my desktop to show you where that particular folder is there. See, so far export. Click that file. Here Excel file is saved. You can open the file, Excel file. Say yes. Okay, and let us wait for the results. So let me try once again. I click the file. I think let us check it once again. Why it's not opening with Microsoft Excel. Do you want to open the file now? Yes. Okay, see, it has result has come. Okay, so you can copy this, you can create chart for this, you can make it bold, you can change the font style, all those. You can paste it your file content wherever you want. You can go and paste it. So this is how you can save all your exports. Let me come back to my software. Let me go to Repo Tables, my table. So this is a portion where you need to select the file from where you will choose the variables for conducting the analysis. The first part of your thing. Let me make it a bit bigger. Yes, this is the first part where you need to select the file which contains all the questions, all the variables. If you click open, you can see all the whatever fields are entered or whatever data is entered. You can see all the fields over here. Then after selecting frequency, we go and select add. We give any particular variable, result is here. Okay. If you want, you can export it. Okay. There's a button called clear. If you click on clear, the screen will be cleared. All the outputs will be clear. Fine. So that is how we can make use of frequencies. Let me go for crash steps. I click the checkbox crash steps. Whenever you want to prepare crash tables of 2 or 3 variables, you can make use of this particular option. So for example, under row, I want gender. I want gender to be in the row side. And column, I want maybe the nativity. So under row, I selected one variable. Under column, I selected another variable. You can say crash tabulation here. Okay. And here in the row section, the config is there. Click on config. You say total. Click OK. Total will appear. Fine. The same side, columns also config is there. Go to config. You can select total. You can select column percentage. You can say OK. So you'll get column percentage now. If you want the row percentage, once again go to config and click row percentage. Say OK. Both column percentage, row percentage, grand total, everything is there. So this way you can create a kind of crash tabulation. So that is also permitted in SOFA. So close. I'm sorry. Let me come to report tables, and I have come to my file descriptive statistics. Now I want to create multi-level tables. How to do that? So come to frequencies, click add. I have gender, say okay. Now I want this gender to be subdivided as per the nativity. For example, out of male, how many are from rural background, how many are from urban background. So that kind of division I want to have within gender. How to do that? Click add under row, just below rows. There is a box called add under. Click add under and choose the field nativity. Say okay. You can see here now. So male is divided into urban, semi-urban. Female is divided into urban, semi-urban, rural. If you want total, once again go to config. Say total. Say okay. The box is ready. So this you can have multi-level tabulation also can be prepared using this option called frequencies. Okay. I say clear, it goes off. I told you about crash stats. Let me talk about row stats. So row stats are meant for calculating your descriptive statistics. You want to calculate mean, median, mode, standard deviation, range. When you want to calculate such kind of things, you can go for row stats. Okay. After clicking row stats, come to columns, click add. For example, I got marks scored by students in the first week. I click week 1. I say okay. See, by default, mean is calculated. I want to calculate something more. So kindly come to columns option, go to config. See, a very, very long list is there. Standard deviation, you want a number, minimum mark, maximum mark, range, then sum. See, all these things I want to calculate. Say okay. You can see here. For the marks, we have mean value, standard deviation, number, minimum marks, maximum marks, the range, the sum, everything is available. So this way, you can calculate all the descriptive statistics using this row stats option. So please understand, this is the format. Here you select the file. Here select the option, either frequencies or crash tips or row stats. And accordingly, either rows or columns you can use. The result will be available here in this white space. Okay. And here you can see something like output. Here view report. See, it is a place where whatever statistical calculations you conduct here, all the tools, all the results, all the outputs will be stored in a separate file. If you want, you can choose a different location, give a different name. All the results will be stored invariably. For example, I click view report and let us wait. Okay, see whatever I have calculated so far. Okay, all the statistical calculations are stored in this particular file. Okay, fine. So view report can be used for that particular purpose. Now the last one is data lists. See, data list just helps you to list all the data one by one. For example, I click add under columns. I select gender. I say okay, you can see here. So first candidate is male, second candidate male, third candidate male, fourth male. So this way, question order wise, all the variables will be listed. You can add one more if you want. Add nativity. Fine. It says first respondent is a male. He is an urban background person. Second person is a male who is hailed from urban. So that kind of question wise data you'll get with the help of this data list option. So that's what all about generating tables. So let me wind up this. I click close. So we have seen enter edit data, import data, report tables we have checked already. Now let's talk about charts, how to prepare charts. So let me click on charts and this screen appears. Let me maximize this. Here many different kinds of charts are there. We have bar chart, we have clustered bar chart, we have pie chart, we have line chart, we have area chart, we have histogram, we have scatter plot, we have box and whisker plot. So these are different kinds of charts. I would like to just demonstrate one or two. For example, I have selected this pie chart. I want to find out how many males, how many females are there in my particular research data. What is the first step? You should select the file name. I have selected descriptive statistics. Second step, choose a chart type. I selected a pie chart. And third, it asks how the values to be arranged. I say let it be value. If you want the count and percentage to be shown on the chart, you check this box so that number and the percentage will be shown in the chart. And which variable is going to be used for this purpose? Gender. So what is the value? Gender. Right? So click on show results and wait for the result. The result has come. So pie chart is ready. Okay, now females 12, 60%. And males 8, 40%. So you can copy and paste, or you can export to any place and you can save it. Okay, you can take it to Excel, you can make a modification and you can take it to a place where you want to paste this particular chart. This is how you calculate, you prepare pie chart. Let me show you another one, maybe a very simple bar chart. Let me choose maybe count, no problem. Either count or percentage, you can choose count. Now this time I want to have a chart for nativity. Okay, for nativity, say show results. Okay, you can see here bar chart is red, urban, semi-urban, rural. A bar chart is ready. Fine. Okay, you can even go for this clustered bar chart. I click clustered bar chart. I say nativity by gender. Okay, I want to have nativity to represent every bar, and in every bar I want to divide the nativity according to gender. See nativity by gender. Okay, say show results. You can say difference here now. Okay, are you getting it? Urban is divided into male female. Semi-urban is divided into male female. So that kind of clustered bar charts also can be prepared based on two values. Okay, so you want to have a line chart. Click line chart based on count. You can have marks. Mark 1. Okay, I simply select mark 1, and this I say nothing selected. Okay, only plainly I want the mark. Show results, and you can see the result, the marks of the students. But I want the same marks to be shown as something like male and female. I want to divide this mark. So what you can do, same place, week by by gender. Okay, by gender. Show results. Now you can see the difference in the output. You can see male marks scored by males and marks scored by females. Both are shown. Here I use count. So mark count comes. I can go for even percentage. I select percent. I show the results. And you can see here the percentage of marks scored by students are displayed. So these are a few examples of how you can create charts in SOFA statistics. I think it's clear to you. I click close. I'll come back to the main homepage. The last one to be seen is statistics. Very important one. I click on statistics. Okay. Once I click statistics, this window appears with these many tests. How many tests are there? Only these many tests are there. Nothing more, nothing less. SOFA provides you the ability to contact only these many statistical tools. One-way ANOVA, I-squared, Pearson correlation, Spearman's correlation, Kruskal-Wallis, Mann-Whitney, Ttest independent, Ttest paired, Wilcoxon Ranks. Only these many tests can be conducted in SOFA. You cannot conduct factor analysis, cluster analysis, dominant analysis, discriminant analysis, reliability tests. So these things cannot be conducted in SOFA. SOFA helps you to conduct only these many tests. 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 tests can be conducted to test the validity of your hypothesis. Okay, let us see one by one. Okay, to begin with, I start with high square. I click on high square in this box and I click configure test. Okay, what is high square? When you want to compare two nominal variables or ordinal variables, you can go for high square test to test whether there is an association between these two variables. Okay, what is the first step? You should select the file. I click this downward arrow and select the file called high square. Already I have some files, high square. I want to know what are the fields. Click open, you can see the fields. Two fields are there, political party and comments. Political party I numbered as 1 and 2. 1 and 2, 1 stands for ruling party, 2 stands for opposition party. And this comments, we asked them whether this lockdown period can be relaxed. Somebody said okay, somebody said no, somebody said no comments. So I just given the numbers 1, 2, 3. So this is an independent variable. Political party is an independent variable. Okay, it is a nominal data 1, 2, 1 for ruling party, 2 for opposition party. And my dependent variables commands given by them. This is also nominal data. I given 1, 2, 3. Yes, no, no comments. Okay. Now I got an idea of the fields. I close the file. Here I have selected the file. This is a file name, and I have to select the variables. What are two variables? I got political party, and I have got comments. This is a independent variable. This is a dependent variable. Fine. I say show results and wait for a minute. Okay. I think something went wrong. Let us try once again. Okay. Oh, I'm sorry. The result has come. Okay, I'll close this menu. Okay, let us do it once again. I select I square. I go to config test. I select the file called I square. I select the independent variable. I select the dependent variable. Okay, fine. Okay. Then I say show results. The result has come here. You can see the screen. How many said yes, how many said no, how many say no idea. And here are the results. P-value and high square value and degree of freedom. The p-value is 0.001. As I told you, you have to compare this value with the level of significance what we have fixed already. I told you universally we have 5% significance. 0.05 is our level of significance. So I have to check whether this p-value is more than or less than the 0.5 significant level or not. In our case, the calculated p-value is less than the level of significance. That is less than 0.05. If it is less than 0.05, then the null hypothesis is rejected and alternative hypothesis is accepted. So what is the null hypothesis? There is no association between ruling party and opposition party with regard to their commands on relaxation of lockdown period. So now it is proved that the null hypothesis rejected. So what does it mean? Alternative hypothesis is accepted. That is, there is an association, there is a significant association between ruling party and political party with regard to their comments on the relaxation during the lockdown period. I think it's clear. Okay, good. Let me close this. So high square is clear. Let me go to correlation. I told you correlation is to be conducted when you got two numeric data and you want to conduct the linear relationship. You want to find out whether linear relationship is existing between these two numerical variables. You can conduct correlation Pearson's. I click configure test. What is the first step I told you? You have to select the table or file name. What is the file name? I got one file called Pearson correlation. Okay. You can have one file. In one file, you can have all the variables. For the purpose of simplicity, I just made a couple of Excel files. So I selected the file. I want to see what are the fields. Click open. What are the fields? Study time and the science marks. So how many hours a child studies in a particular week and the marks scored by him in science. So both are in numbers. So you can go for correlation test. So let us conduct one correlation test. What are the two variables? Under group A, select our independent variable called study time. Group B, select our dependent variable called science marks. Okay. What is the hypothesis? There is no difference. There is no correlation between number of hours spent, number of marks scored. This is our hypothesis. Click on show results. You can get the answer here. Okay. You can see here a thick line which shows the mean value, and you can see here when the let me make it a little bigger. Okay, now I think it's clear. See, when the number of hours spent by the children increases, correspondingly the marks scored by them also increases. So it means there's a correlation, but we have to prove it statistically. How to do that? You have to take this p-value. What is the p-value? 0.01869. This is to be compared with our level of significance of 0.05, and definitely p-value is less than 0.05, and so the null hypothesis is rejected and the alternative hypothesis accepted. That means there is a significant correlation between study time and the science marks of the respondents. Here you can see the R statistic is 0.721. You can see it is a positive number. It means that there is a positive correlation between study time and science marks. That means when study time increases, science marks also increases. So there is a correlation. There is a positive correlation, and 0.7 is equal to something like it's got around 70% correlation. Is a good correlation. Fine. That's about correlation. Let me close this. And I can conduct Spearman correlation. When I'm supposed to conduct, when the data what you have or ranks, you got two ranks. When you want to compare two ranks, you cannot conduct Pearson. Instead, you can go for Spearman. Click configure test. And here, what is the name of the file? Pearson correlation. And what are the variables I have got? Click open. You can see two are there: teacher 1, teacher 2. Okay. So teacher 1 student went to teacher 1, teacher 2. The teachers have graded. That way, 8 students went to both the teachers and they were graded. We want to see, is there any rank correlation difference between teacher 1 and teacher 2? Is there any correlation between teacher 1, teacher 2? Fine. Now let me come to my table. I selected the file. Let me select the variables, teacher 1 and the teacher 2. Teacher 1, teacher 2. Click on show results. You see, the result has come. Okay. You can see here the teacher 1 and teacher 2 there. Is a teacher 1, teacher 2. You can see whether it's a correlation or not. Okay. You can see here when the score of teacher 1, see, this is a mean value. So a score of one teacher score is increasing and the other teacher score is also increasing, but it's not in a good shape. So let us check. Okay. We have to check it statistically. Just by seeing the graph, we may not be able to come to a conclusion. Here, p-value is 0.046. It means that it is less than 0.05. So null hypothesis is rejected and alternative is accepted. That means there is a significant correlation between the ranks given by teacher 1 and teacher 2. But there is a negative correlation because the R statistics is minus 0.714. So there is a correlation, but the correlation is negative. That means when one teacher gives more ranks, the other teacher gives less ranks. But there is a correlation. Fine, I think it's clear to you. Let me close the window. So I square is over, two correlations are over. And let me come to this one, t-test. Let us do t-test now. Two t-tests are there. One is independent sample t-test. Another is paired sample t-test. Fine. Independent sample test is used when you have got only one set of one independent variable, one dependent variable, and they are not repeated samples. So let me take t-test independent. Let me go to configure tests. Let me choose my file. What is the name of the file? Ttest. So I selected a file. Okay. Now I want to see what are the fields. Click on open and you can see the fields. But the first field, driving time and errors. So driving time, it has got two levels, 1 and 2. 1 stands for night drivers, 2 stands for day drivers. So two, those who are driving in the night time and those who are driving in the night time. So two different types of drivers. It's an independent variable having two levels. What is my dependent variable? Number of errors. How many mistakes they commit when they are driving. So we have collected the numbers. They are in numbers. They are dependent variable. So I conduct independent sample t-tests. Okay. And what is the average variable? What is my dependent variable? Errors. Okay. What is my grouping variable? That is what is my independent variable? That is my driving. So driving is group 1, night 1, night, and group 2, day. So my independent variable is errors. My dependent variable is driving time. This got two levels, night time and daytime. So two levels are there. I selected both the levels. I say show results and wait for the results. And you can see the results here. It says p-value is 0.001. It means that it is less than the significant level of 0.05. The null hypothesis is rejected and the alternative is accepted. It means that there is a significant difference between the time drivers and the night time drivers with regard to the number of errors they commit. So there is a significant difference. And the t statistics is 5.4555. Degree of freedom is 14. And if you calm down a little bit, you'll understand something more are there. So for example, nighttime drivers, their mean error is 8.87. The daytime drivers, their mean error is 5.75. So there is a significant difference. And this is standard deviation, minimum maximum scores, and this is kurtosis and skewness. You can see here, both kurtosis and skewness, they are between -1, -1 and +1. So that means the data is normally distributed. Even you can see this last column 7, normal. If this value is more than 0.05, if this value is more than 0.05, it means that the data is normally distributed. So the data is normally distributed. The data is having number in dependent variable. Independent variable has got only two levels. So I conducted independent sample t-tests. Fine. And here there is something called O'Brien's test for homogeneity of variance. Okay, they say that when you got two different groups, night drivers, day drivers, what about the difference, variations existing in each group? So among the night drivers, one difference may be there. Among the day drivers, another difference will be there. So this test tells you whether the variance in each group is similar or not. There is a homogeneity. There is similarity of the range of variance. It should be same. It should be similar. If the similarity is there, if homogeneity of variance is there, then you can conduct independent sample t-test. Okay, always you have to go for manual with me. Fine. Here, how to check whether my data is having homogeneity of variance or not? It's very simple. You just see the results here. It is 0.49. If it is more than 0.05, then it means that the assumption is met. You can conduct independent sample t-test. In our case, The O'Brien's test for homogeneity of variance is 0.49. It's definitely more than 0.05, and so it is accepted that our groups of data have homogeneity of variance. So we can go ahead with independent sample t-test. There is no problem. I think it's clear. Independent sample t-test. Okay, let me close it. And let me go to man-Whitney U-test. I click configure test. I'll use the same table. Let me see the fields which I'll be using for this particular purpose. Here you can see club name. Two clubs are there. One is Aravind Club and another is Subha Club. So I've taken some students who belong to two different clubs for a movie. They watched the movie. I told them to give ranking for this movie out of 20, out of 50. They rank 1, 2, 3, second, 5th, 100th, 13th. They given ranking. So my independent variable has got two levels. Aravind Club, Subha Club, two club members. This is my independent variable. My dependent variable is ranking. It's not numeric data. It is in ranking. It's ordinal data. So I cannot conduct independent sample test. So I will be conducting man-Whitney U-test. Okay. What is my dependent variable? My ranking. How it's going to be grouped by? Based on the club they belong to. So one is Aravind Club and another one is Subha Club. Two clubs are there. Click on show results. You can see the results here. A very, very simple result. T value is 0.011. Definitely it is less than 0.05. That means null hypothesis is accepted or rejected. It is rejected because it's less than 0.05. It means that there is a significant median difference between Aravind Club and Subha Club with regard to the ranking of a particular movie. So there is a significant difference. So use statistics, and here you can see here for one club the median is 36 and the other club the median is 58. So there is a difference, and that is proved statistically with this p-value. I think it's clear to you. Let me close this window. So we have seen t-test independent and we have seen man-Whitney. Next, I'll go to paired sample t-test. I click configure test. I say open to see the fields. So I'll be taking these two fields. Okay. I have selected some 14 children. I gave them one test in the morning when they come to school, very fresh. I gave them one test. And in the evening, maybe around 3 o'clock before they go back to home, I gave another test. I want to check whether there is any difference between the marks scored by students when they write the examination in the morning hours and when they write the examination in the evening hours. I want to check whether is there any mean difference. So you can see marks scored AM in the morning, marks scored in the afternoon. You see both are numbers. Both are numbers. So I can go for paired sample t-test. Okay. So let me close this window. I select AM and PM. By default it is there. Otherwise you can select. Okay. AM, either AM PM or PM AM. It doesn't make any difference. So if one is AM, another should be PM. So I want to conduct a paired sample t-test before treatment, after treatment, before this class, after this class. In such kind of environment, you can go for paired sample t-test or correlated sample test. Both are same. Click on show results. And you can see here, it's very, very simple. AM, the mean value is 6.57 marks. And PM, the mean value is 4.42. It means that the mean score is higher when they write the examination in the morning hours. Okay. And it has got minimum, maximum. And how can I prove whether this is statistically different? Please come up, see the p-value. It is 0.001. It means that it is less than 0.05. The null hypothesis is rejected. And it means that there is a significant mean score of difference in the marks scored by children when they write the examination in the morning and in the evening. This is the t-value and this is the degree of freedom. I think it's clear to you. Let me close the window. I'll go to Wilcoxon Ranks. This also same like paired sample test, but only things here, the data is not in numerical form. It is in terms of ranks. Okay, let me select my file. Okay, the same file. I click open. Here two things are the candidate 1, candidate 2. See, there are 10 teachers, those who are evaluating two candidates. One candidate goes to all the 10 teachers and second candidate goes to all the 10 teachers. We want to see, is there any difference between the ranks given to one candidate and the ranks given to another candidate by the respondents? Okay, one teacher another teacher, same set of respondents, same set of students. So since they are all ranks, they are not marks given by teachers, they are the ranks given by teachers. So since the data is not a numeric data, we go for Wilcoxon side ranks. So what are the two values I want to check? Candidate 1 and candidate 2. So I selected both the candidates and I click show results, and you can see here candidate 1 the median value is 14, candidate 2 the median value is 8.5. So there's a difference, but is it statistically significant? Please come up, look at the p value. It says that it is 0.02, and definitely it is less than 0.05, which means that the null hypothesis is rejected. That is, there is a significant difference between the ranking of candidate 1 and the ranking of candidate 2 by 10 teachers. That is our hypothesis which is being tested now. I think it's clear, same like paired sample t-test. Let me close it. So we have seen paired sample t-test and the Wilcoxon Ranks, and I got two more tests. One is ANOVA and another is Kruskal-Wallis. Let me go to ANOVA. I click ANOVA. I go to configure test. Let me select the file for ANOVA. There's a file called one-way ANOVA. I select the file. Let me see what are the fields they have. Click on open. You can see 4 fields are there. Let us see first 2 fields. Hint type and minutes. 2 things are there. So I divided respondents into 3 groups. The students, those who are having, those who have got some hint, those who did not get any hints, and those who got some kind of hint. So 3 groups are there. For example, I have given some puzzles to them. I have given some puzzles to them, something like a jumbled word, something like that. I divided them into 3 groups. In the first group, I told them the first letter as an answer, as a hint. Second group, I have given the last letter. And the third group, I have not given any hint. So there are 3 groups of respondents. My independent variable is hint type. There are more than 2 levels. Those who got first letter as hint, those who got last letter as hint, those who did not get any letter as hint. So 3 groups of respondents. Now, what is my dependent variable? Number of minutes. In how many minutes they were able to find out the answers for all the jumbled words I have given to them. So my dependent variable is numbers. Independent variable is having more than 2 levels. So you can go for one-way ANOVA. Let me close it. Let me come back to this. Average is minutes. Group by hint type. You can select by hint type. And first letter, last letter, and no letter. So it starts from first letter. It goes up to no letter. So 3 levels are there. I click show results and wait for the result. The result has come. You can see here, those who got first letter, they finished their what is their mean time, mean minutes, 15.6. Last minute they took more time, 24 minutes. No letter they take some more time, 28 minutes. So it means that there is a significant difference, because only 15 minutes, 24 minutes, 28 minutes, so there's a difference. But is it statistically different? We have to find out. Before that, you can see here standard deviation. And the kurtosis and skewness both are between -1 and +1. That means that the data is normally distributed. And you can see column here 7. Here all the values are more than 0.05. It means that the data is normally distributed. Fine. Let me come up. You can see here the homogeneity of variance test shows that the answer is 0.5. It is more than 0.05. It means that the data is the groups. We have got 3 groups of people. The variation in each group is somewhat similar. There is no much variance. So the assumption is accepted. We can go ahead with this one-way ANOVA test. Okay, that is the meaning of this homogeneity of variance test. Let me come up to see the final answer. You can see between and within. See, between says that what is the difference exists among the group, 3 groups, first letter, no letter, and last letter. Okay, and within says that the percentage of error which we cannot calculate using this particular statistical tool. And between is more, 886, and error is only very less. It means that our statistical test is able to reliably convey the results of this test. Sum of squares, you know very well. If you multiply, if you square the variance and total, you'll get some sum of squares. And the mean sum of square is equal to sum of squares divided by degree of freedom. You get a mean sum of squares, and this is f value, and this p value. Check the p value. P value is 0.001. That is the p value is less than 0.5. If it is less than 0.05, it means that the null hypothesis is rejected and the alternative is accepted. That means that there is a significant difference among these three groups of respondents with regard to the number of minutes they take to solve the jumbled words. So that is the meaning of this. Fine. I think it's clear. I don't know what's clear to you. And let me close this window. Let me come back to the last test. What's the name of the last test? This Kruskal-Wallis. So both ANOVA and Kruskal-Wallis both are one and the same. The data is numeric, data is normally distributed, go for one way ANOVA. If you have collected the data as a rank or the data is not normally distributed, you can go for Kruskal-Wallis. So I have selected the file, click open, you can see here. See, three groups of respondents are there, so people want to relax. I give them three different techniques. For one group, I have given some tablets. For another group, I have taught them some hypnosis techniques. The third group, I taught them some exercises. So three groups of respondents. My independent variables having 3 levels. And after a particular period, maybe 1 month, I told them to rank how relaxed they feel now. So they have given their ranking. So it's not a numeric data, it is a rank data. I have to go for not one way, now I should go for Kruskal-Wallis. Close it. Let me come to Kruskal-Wallis. I have to select the variable. What is the variable? Ranking. And what is a group? I think it's a relaxation technique. 3 groups are there. Exercise 2, pill. So 3 groups are there. Click show results. Here is the answer. You can see here exercise 35, hypnosis 27, pill 16. That means there's a difference among the groups. But how to prove it statistically? Please come up and look for p-value. P-value is 1.319e minus 3. Okay. See, it means that when you say it's e minus, it means that it's less than 0.000. It's less than 0.001. And since it is less than 0.05, it is understood that the null hypothesis is rejected and the alternative is accepted. It means that there is a significant difference among these 3 groups of respondents with regarding to the relaxing technique that they have been using it. Fine. So that is the result of this Kruskal-Wallis test. So fine, we have seen all these kinds of tests and the implications. And before I conclude, I will take just 2 minutes of my time to tell you one thing. Here, see, if you are very clear on which statistical test you have to use, you can straight away go for this particular option, select the test, click configure test, and then you can conduct the test absolutely no problem. For example, you are not clear. So whether I should go for ANOVA or high square or Man-Whitney or Ttest or Wilcoxon, you're not sure about that. When you're not sure about which kind of statistical tool you need to apply, then you can get the help from SOFA Statistics. Here's the option, second option left side, or get help choosing below. One option is there. So you can use this particular option. This software will help you to decide which statistical test you can conduct in a particular environment. So let me show you how SOFA is going to help you. See, for example, I have to tell the system how many groups are there, whether your independent variable is having 2 groups or 3 groups. For example, your independent variable is having 2 groups, okay? And it is asking whether that dependent variable is distributed normally or not normally. So you can tell whether it is normally distributed or not. It is normal. That means your independent variable is having 2 levels and it is normally distributed, and it tells you you have to conduct independent sample t-tests. So SOFA Statistics automatically calculates and tells you that when you are having 2 groups, when your data is normal, you have to conduct t-test. Fine. See, you have got 2 groups, but the data is not normal. The data is not normal. You can say, it says that you have to select Man-Whitney. So software tells you, okay. For example, you are having 2 groups, data is normal, but they are paired sample. You have got paired data. Then what is to be done? It says that you have to conduct paired sample t-tests. If This is not normal, you have to go for Wilcoxon. So just by clicking one or two options here, this particular software will tell you what statistical test you have to conduct. I think it's clear to you. Now, when your independent variables having 3 levels, okay, more than 2 levels, it has got 3 levels. If data is normal, you have to conduct ANOVA. The data is not normal, you have to conduct critical values. So just by clicking the options on the left side, the software will itself suggest you what statistical tests you can conduct on those variables. Fine. Let me calm down. Here, test show with there's a relationship. You click that. If your data is only nominal data, you have to conduct high square. If it is a ordered data, you have to check whether the data is normal or not normal. The data is normal, you have to conduct a correlation Pearson. The data is not normal, you have to conduct Spearman correlation. Fine. So this way, this software will help you to decide whether a particular situation warrants you to conduct any one of these 9 tests. Fine. So let me close this window. And we come back to the home page. As I told you, we have talked about enter edit data, import data, Repo Tables, charts, statistics. If you want to take a backup, you click on backup, you select the folder. Whatever you have done all these days will be saved in the backup. And whatever databases, whatever files you have, all those things will be taken a backup. And click exit, it will be come out of the software. So this is what all about SOFA. So you can please download the SOFA. You can install it and you try to make use of all these options. So my best wishes. Thank you so much.